So in this video I will explain you how to actually build an Ethernet frame. We remember from the last video that Ethernet was designed to synchronize the time intervals between network devices, to specify the recipient and the sender of the data, also to detect corrupted data, and to detect and resolve collisions that can occur in a shared medium. So this is what an Ethernet frame actually looks like, and by the end of the video you will understand all the parts of this. So let's start at the very beginning with the preamble. The first thing that the preamble does is it puts a sequence of ones and zeros on the network. So this is actually made to find out how long one bit should be. So when you have 64 bits that you put on the preamble, and you always do 10 10 10, and you do this with your own clock and time, the recipient interface might have another clock running with another time scope, but it can figure out how long one time interval of one bit is that is coming from the sender. So now you see B is receiving some data and C is receiving them data, and they're both synchronizing their clock, even though computer B or computer C might later find out that this data is actually not for them. So another thing that would happen here is that media access control address was invented. You put two media access control addresses on the frame, one for yourself, which is the source MAC address, and one for the destination, that's the destination MAC address. And the interesting thing about the media access control address is that it exists only once. It's very unique, and the first 3 bytes are the part that classify the vendor, and the last is the serial number of the device. And as I said, they're very unique. And this way you can identify a device on the network specifically and can say who the data is for and who sent the data. The next part of the protocol is the EtherType. And the EtherType is a 2-byte field where you can actually do 2 different things. You put in a specific number, and there is some RFC on the internet that tells you which type of protocol is this. For example, 0800 means that you do IP over Ethernet, which is probably the most frequent Ethernet type. If the number is less than 0600, this means that this number represents the length of the frame. And the length of such a Ethernet frame can be between 46 and 1500 bytes. And there's actually a reason why the frame length has to have a certain minimal length, which I will explain to you in the next 2 videos. After this, of course, there comes the data and the payload of the Ethernet frame. Even if you only wanted to transfer 1 bit, you have to have a payload of at least 46 bytes, plus the additional Ethernet header, which also has to have a certain length. So in order to solve all the problems that Ethernet has, you have to have a certain length. And last but not least, there is the checksum, which is a sum calculated by the entire data on the frame. And if you receive the data and you calculate the checksum algorithm on the entire data, including the checksum, the result will always be 1. And if something gets wrong, the frame will be dropped. And actually the CRC algorithm can not only detect errors but also correct a few, but this will hardly ever happen, because if you think about a situation where a cell phone might corrupt the data, then probably the entire frame will be corrupted. It's very, very rare that only one piece of information gets corrupted. But the other interesting thing about corrupted data is that if a device detects an error, it cannot do anything about it, because obviously it doesn't know where the data comes from, and it cannot send something back to the source and requesting the data again. But also the source doesn't know that there was some error. So these kind of things will be handled by other protocols that are in a higher layer of the Internet Protocol stack, and this is quite important. So to sum this up, the Ethernet frame design was created to synchronize the clocks of different devices on the network. It was also designed so that the sender and the recipient of the data can identify themselves, and data frames can be sent to specific network interfaces on the network. It also can detect some errors, and it can send a flexible length of data, though a minimum length of 46 bytes is required. One thing that we did not talk about right now is that this design cannot standalone fight the problem of two devices sending data simultaneously. But we will come to this in the fourth video of this MOOC. So I'm René Pickard speaking, and I hope this video was helpful and interesting for you. And I hope to see you in the next video.